Yeah, I'm Tyranid. I taught yesterday more for sort of theoretical basis on the PSP work, and it was quite dry, quite a long sort of presentation. So today, hopefully, is a bit more interesting. It's going to be more practical based. I'll show you sort of the tool chain, some of the development tools, and hopefully, I'll try and quickly knock up some very simple demo just to show sort of how quickly you can get something done on the PSP. Right. So yeah, I've gone through that. So the compilers. We spent a lot of time trying to build the compiler toolchain up, all based off the GNU compiler collection, GCC, and it's quite a modern revision. There is actually ports for the 4.1 branch as well, so that will get you C and C++ development, and it supports the main CPU, including some of the vector processor instructions, etc. Comes with libc, also allows you to use standard C++, so you can write all your usual C++ type code, STL, etc. if you want to completely waste memory on your embedded device. And it is designed for Unixy style systems, so Linux, etc. But it can be built on the Windows. It's just generally easier to use if you run it on a Unix-like platform. The SDK is all very well having a compiler, but without the ability to access the internal functions Sony provide in the kernel, it would be fairly difficult to use. So we also, as a parallel development, we worked on the SDK, which is a freely available, reverse-engineered system which we've taken from games, etc. We've found games where they've accidentally left in all the debug information, things like that. But the PSP makes it quite simple for us. It's got a lot of exported functions in the kernel, so we don't actually have to write a lot of code in order to get this to glue together. It's more a collection of tools, basically. And it has basic debugging functionality, all the tools you need when you're building your applications, and a large collection of samples, which is relatively rare for the PS2 dev people to actually do. 60 plus samples covering graphics, audio, etc. Of course, if C and C++ isn't for you, there are other development environments. There is Port of Lua, with PSP-specific extensions. There's Python, and also if you want to program basic Flash stuff, the PSP kernel itself provides a Flash player. Right. So it's all very well. You build your application, and it obviously crashes. It's going to happen. It's a C++ application. You'll accidentally hit a null pointer or whatever. So what can you do about this? The normal thing which happens with most console, sort of free console developments, is there's not a lot of debugging you can do on the device itself. It's generally a case of here's an application, run it, and you might get some screen printf or whatever to help you debug that. And that's sort of blind debugging. You don't need any custom software to get code running on the PSP. You just stick it on the memory card and run it. So you can do blind debugging if you like. And the SDK will help you in that regard. It will allow you to printf to the screen or out of the serial port. Adds exception handlers. You can trace around, stack traces, enumerate threads exactly. But you've got to do it all yourself, which is not particularly a good use of your time. So one of the first things which came out was a tool developed by Hitman, which allowed you to, on the device, disassemble code, look at threads, look at the system operation, primarily as a hacking tool, but could also be used as a development tool. But it's not exactly exactly convenient, even though some of the work is taken away from you. Doing all this on a PSP screen with the PSP joypad is not the simplest interface. So I then worked on PSP Link, which I basically stole the name of PS2 Link, which was the equivalent on the PS2, and implemented what is in effect a generic homebrew launcher development tool, hacking tool, which you plug into your PC over a normal USB cable. You can also access it over serial or Wi-Fi, but these days I would only ever recommend running it over USB. But that comes with basic TTY, so you can printf to it, you can even call it fgetString and get text from the user sitting on their PC. Allows you to access the PC's file system, which is very, very useful. It means you don't have to transfer your files to the PSP memory stick, you can just run them straight off the PC. Exception handlers, so when things all go horribly wrong, it will at least print something reasonably useful for you, because the default is for the PSP to shut down, which is not useful at all, really. And you can also do GDB over it. GDB is a nicely documented protocol. It might have been nice to have, say, a Visual Studio interface, but Microsoft don't really publish those sort of details. So I have to go with GDB. And that works pretty well. Hopefully I'll try and just run it up soon. So one last thing. It originally worked only on 1.0 and 1.5 kernels, the old accessible firmwares. Now with the new custom firmwares available, it will actually run on the latest 3. Whatever. I'm running on 3.10. Most likely you'll be able to get it on 3.3 when they eventually put out a custom firmware for that. So, you can see, PSP, normal USB cable stuck in the top, nothing special at all. The heart of it is this USB host program, which basically crashes. That's nice. This basically mediates between the USB device and the file system. And it also provides a set of TCP/IP servers, which you can then use for your own purposes to do generic data transfers over the USB cable, without having to implement it yourself, which is kind of useful. And it's the basis of the shell which you actually control PSP Link, as well as GDB and my remote joystick protocol. So we can have a look at what drives we've got mapped. You can have up to 8 file system devices, all mapped to different parts of your file system. You can map it to root if you like, or you can map it to anywhere in your file system whatsoever. So if I just mount I'll mount the samples directory for the SDK. Now, okay. So that is now listing actually on my local file system. It doesn't look particularly impressive because it's running in a terminal, which is on my local file system. So, but that is actually going all the way over to the PSP and then coming all the way back again. If I just run up, yeah, that's still running. Yep. Okay, so hopefully. So to run an application out, these are all pre-built. They're just simple make file, spits out a file. To run it, all you do is pass the path to it. It's very simple. And if I run that, and hopefully you can see it now running. And that is actually running on the PSP as well. This is only for real demonstration purposes. The output works quite well, but it doesn't. It hasn't got the best performance sometimes. So you've written your app, which you've run straight off your own PC, and when you finish with that, because of the way the PSP works, it doesn't have the concept of processes. You can't just kill the process. What you do is you basically reset the PSP. And if you press Alt plus R in the shell, it does that. And now I'm back to my clean state again. So you can then run another app and do whatever you want. So again, nice Mystify screensaver on the PSP. Not exactly the most complicated piece of code, but that just sort of shows the demonstration of how it can speed up your development time. Before, you would have to go back to the main menu, turn on USB, copy your files, stop USB, go to the menu, click go. It was quite a long turnaround time, but this you can turn around in 3 or 4 seconds, really. And the performance is you get about 10 megabytes per second over the file system. So for what you're likely to use it for development purposes, it's probably perfectly acceptable. So right. Yes. So let's see if I can actually try and go through some of the parts of a PSP program. There's various bits of sort of boilerplate you'd want to add to it to get something to work. So you can look through the samples, but there's normally a lot more information in the samples than you need. So I'll try and go through a very basic run-through of developing an application. So I'll just close that down. Right. So the PSP SDK comes with lots of samples. As I mentioned, it also comes with very simple templates. So basically a main.c, and in this one, it's a template of a simple hello world, and that will print out to your PSP Link terminal. Hello world, obviously. Now, probably there's only sort of 2 lines in there which would actually distinguish that from a normal PC Hello World application. The first being the PSP module information. This is a necessary line because you need it to get your programs to run. The name is arbitrary. You can put whatever you want into the name, make it descriptive so you know what it is. And you've also got thread attributes. This isn't, because the VFPU, the vector processor, has a lot of registers. You don't want to context switch it that often, so there's actually a thread attribute you have to set to get the vector processor to be enabled in your thread. Therefore, the kernel can optimize itself so it doesn't have to context switch your vector registers every time. So I just make a few changes to this. So demo, obviously hello world, and then I'll use one of the thread functions, which will basically stop the thread, let it sleep, but it won't actually exit the thread. If you just return from that, what will actually happen is the module will actually get just unloaded, and then nothing will happen. So it'll print hello world and then disappear. But for demonstration purposes, it's probably quite useful to see it out in action. So if I just bloody hell. The make file is fairly simple as well. Relatively simple. We provide template make files so that you can. It's fairly simple to implement your own application. Target is just the name, so again, demo. Objects is the list of files, so if you add extra files, you can add an extra object to that. And you've got C flags, etc. And at the bottom, a couple of lines which allow you to import that template make file to make everything work. So if I type make, surprise, surprise, it builds it with the wrong file name. But anyway, help if I save it, wouldn't it? Right. Okay. So if we go back to our USB host, if I mount my demo directory, And now it's mounted on host 0, so if I list that, we can now see our demo. And if we run that, it says hello world to us. Well, there we go. Right, you can job done. So it's very simple. From here, PSP Link allows you to enumerate a lot of information about your system. First thing you probably want to do is type help or question mark, and this gives you a lot of categories for different things you can do. So under module, you can list the currently loaded modules, load them, unload them, kill them, all manner of things, plus some sort of hacky stuff. You can hook system calls so that you can trace problems in your code. Also looking at imports and exports, a lot of hacky stuff. But if I do module list, we've got all the kernel-y ones. And then right at the bottom, we have our demo. We can then use that information to get even more data about it, which gives you your entry point, where it's loaded into memory, and you can then use that information to dump the actual data which is stored in memory. And also, because that is actually code, you can disassemble it. All very simple. Can be useful if you're trying to track things down, but it doesn't have support for source files, etc. So you can disassemble your code, but there is no real easy way of correlating that back to your original application at the current time. But anyway, again with the thread lists, our user main at the bottom, that's our main thread. And that's now currently sleeping. It's actually classed as a wait state, and it will just do absolutely nothing and just sit there forevermore. So we reset it, and the shell has command line history, most of the stuff you'd sort of expect from a shell, tab completion, etc. If we do that, it doesn't exist anymore. So we've gone back to a completely clean state. Right. Let's see if I can actually produce something slightly more useful. We get rid of that. Strip out the commenting. Right. So, probably want to try and put in some graphics. Now, the graphics are normally the best way of using the graphics system is to go through the graphics utility library, which provides a relatively sort of simple interface to the underlying hardware. You could poke to that hardware more or less directly, but realistically there seems to be very little point to doing that. So let me just... Unfortunately, while it is fairly simple to use, it's quite verbose. It's a lot of lines of code, so I'm not going to sit here and type them all. So hopefully I have something I can copy and paste from. I know this is cheating, but we don't want to be here till the end of the day. Now, the first line I've added, this is our display list. We've given it quite an amount of data. And the key thing to bear in mind is it's got to be aligned to 16 bytes, otherwise it tends not to work, because it uses DMA to transfer it into the graphics hardware. But you don't really see that because the application hides it from you. Unfortunately, it can't hide the fact that it has to be aligned. And let's go for this stuff. So this is, as I say, why I felt it probably wasn't worth typing it in manually. There's a lot of typing in that. Some of the things GU start basically says take this list, and this is my current list, and start building in that file. Draw buffer and display buffer set where the graphics engine is drawing to, so this is double buffering, and then the display buffer is what's actually on the screen at the time. You've got various other sort of bits and pieces, offsets, viewports, and these GU enables. It has the graphics utility has a lot of different flags which you can set, and there's GU enable and GU disable. So some of these cull face, if you have your polygons pointing backwards, which is dependent on front face, which is saying it's if you've got your vertices in a clockwise order, that's the front face, and these will cull them, so you get back face culling. Clipping, which realistically is quite bad on the PSP. You have to do your own clipping if you want to do something serious, but for basic 3D work it should be sufficient to use the onboard clipper. And textures 2D, which will enable textures, but I'm not going to enable that quite yet. Let me steal a bit more information. Right. So this is setting up some video RAM buffers. We've got our 2-frame buffers and also a Z buffer which we're setting up, and it sets them up with certain color types. So in this case the frame buffers are 32-bit color and the Z buffer is 16 bits in size. I need from that I need to pull in some basic files. So we go to our make file, if we type adds that, and then we need to link in the GU library. So hopefully that will now build. If it doesn't, I'm in trouble. And it doesn't. What did I do? Oh yes. So I tried to make this quick, but obviously it's failing at the first hurdle. Okay. Right. So that's doing the screen initialization. Once you've built your list, you have to call finish and call GU sync, and that will then basically say, okay, send my list to the graphics processor, and it will actually go and do something. But obviously, as you can, I assume you can probably tell, it's not going to do a lot. That's purely the initialization side of things. To actually do some real work, if I copy and paste one last little bit, and we have a very simple clearing function. So we clear it to a certain color. We also want to clear the Z buffer, and we call GU clear, which will then set that will all build it into the list, and it will say I want to do this, this, and this, which will allow me to clear the buffer. We call GU finish and GU sync, which should then render it to the back buffer of our double buffered system, and then all we have is we wait for v blank, which is a standard wait state, and then we swap the buffers over, and hopefully this should clear the screen for us with that color. I'm hoping. Again, not exactly useful, but right. And it didn't work. What did I do wrong? That's just sorry. It's obviously not my day. Yes. Well, I could sit here and try and debug that, but it's probably not worth the time. So we'll see if it's actually running our code, and I'll try and run it inside GDB, because obviously debugging. See if we can debug it, see what I'm actually doing wrong with that. So if I reset that, so we need to make sure that we have debugging enabled. Whenever you build an application, by default it won't actually put debugging information into it. So if you add the -G switch to your C flags, you should it should then output your debugging information. So without that, it would be quite difficult to debug. So to use GDB, we don't pass it the direct path. We actually use the command debug and pass it the executable file. So that's now loaded our USB GDB server. Any of you who's used GDB remotely, there's a GDB server which this is basically emulating that protocol. And we can then do, if we do, file, demo. Okay. So, as it's a remote debugger, we have to connect to the device. But because the USB hostfs mediates between the USB and TCP/IP, the actual socket server is on your local device on port 1001. If you do that, hopefully you can see the code at the top, and it started for us. So if I just do break on main, and there we go. Very simple, usual stepping through. It will go a bit weird sometimes because optimization and MIPS can completely reorder the code. So when you're stepping through, sometimes it just decides to go in strange places. But you can go from there. You can print out your variables, etc. This can also be integrated with applications such as Eclipse, which provide GDB integration. So people have managed to successfully build an entire development environment, and you can debug inside Eclipse directly, and you can build your applications in Eclipse. It works quite well. I'm not a big fan of Eclipse really, but I think it is good that it can be done so relatively easily in that regard. So just go through some of the things. And so it is actually calling our code, but I've obviously messed something up. Yes. Well, I'll just have to cheat, I think. And I'll steal that one. I don't want the MP3 player really. There's a lot of sample code in terms of right. Get in the way now. Hey. So hopefully this will actually do something. If it doesn't, I'm in trouble. Right. Okay, so not exactly the most fascinating of demos, which I was going to end up with, but it's a relatively quick turnaround time when you don't break things. So, oops. Seem to have lost things. Okay. So, right. One of the things I've added to this is you can do the swizzling. I talked yesterday that textures are read from memory using small units, and it's actually more. You get much higher performance if you can swizzle your textures beforehand, because it can then read them sequentially instead of having to pick and choose bits out of memory. So this is a very simple function to do it, which is basically stolen from the SDK samples, and it just basically reorders the blocks. And realistically, you'd want to do this offline, but for sort of demo purposes, it's shown actually working during the operation of the system itself. And then the main loop, basically, all it does is it goes around and draws our squares, which it does that using the GUM library, which allows you to pass it vectors to say, I want to translate these vertices, I want to rotate around set axes, and that's all that's doing. And as you can see, there's projection, view, and model, parts of the matrix stack, fairly simple to use, and is also relatively well documented. And it means then you don't have to write your own code. This can also make use of the vector processor, and so you can get the benefits of vector processing without actually having to implement that yourself in the in actual low-level assembly code, which can speed up development quite a lot. Now, to enable swizzling on the textures, you need to set the texture mode correctly. If you set that to false, if I then rebuild that, and if I run that, now you can see, hopefully, I don't know whether you can actually see from that, but the textures are now all sort of changed in block size. So there is in the SDK the samples which show the performance benefit of doing all this swizzling, and you get sort of a factor of 5 or 6 times in terms of performance if you do that. So it's worth bearing in mind. It's one of these things to stress that when you're trying to develop 3D applications, and you get bad performance, then that is something to really important you've got to do. I don't know whether I've got lights in this or not. The graphics engine does have its own sort of lighting model. You can do point lights and the ambient lights, and you can just set those up fairly simply and get it to implement lights for you without you having to do any of the hard work. Again, this is all sort of documented. And the SDK, I mentioned briefly that the SDK had a set of documentation. So if I try and find it, this is installed when you install the toolchain off from the main installation. You actually get this all pre-configured for you. So, it's basic Doxygen documentation, but tried to categorize it into all the important areas of the system, and hopefully somewhere you'll find it. Graphics Utility Library, right. So this is your documentation for all the various graphics utility functions. So you can have, it'll tell you clear color, give you information about the parameters, and you can just sort of search through that and find the functions you want. They should all be documented. There might be the odd one which isn't, probably because we don't really know what it necessarily does, or it's self-explanatory. So yeah, one of the because it's all built into lists. Basically, you pass it in your set of vertices you want to do. You can use index vertices, so you have a list. You have a common list of vertices, and then basically a list of which ones to pick out from that. Or you can just pass it your own specific vertex formats. And then when you want to actually draw something, you pass it into the draw array function, which will take a list of these vertices and basically just send them to the graphics engine to render. There's various primitives, so there's triangles, lines, points, triangle strips, triangle fans, basic sort of polygon primitives. And you also here specify, in this case, we want 32-bit float texture positions, 32-bit color, and also floating point vertices. And that can be set into a number of different formats for size and performance reasons. There's 8-bit, 16-bit fixed point formats for things like vertices. And let's try to see. That's pretty much in terms of going through sort of some of the things you might want to look at. Really try and look at the documentation for the graphics utility and the matrix utility, the GUM library, because they're the sort of workhorses of doing the graphics work. In terms of audio work, the SDK comes with a fairly simple audio framework, which allows you to just basically get a callback when it needs more PCM data. So in that you can then decode MP3. There's also samples around for the virtually free, at least processing-wise, A-track-free decoding. That's complicated slightly because of the way the PSP kernel works, but for the most part, it gives you a lot of benefit for the hassle you have to do to implement it. But if you want to bypass all these nice utility functions, you can actually look at the code for the SDK. It's all freely available, and so you can re-implement your own at the sort of low level if you're so inclined. But for the most part, I can't see it being a major concern in that regard. So I'll try and show some of the other, because probably you might want to actually know what the graphics libraries are actually capable of. So, hard to see. So you got in here sort of blending samples, blitzing speed tests. You can have paletted texture formats. So there's information about CLUTs and stuff like that, environment mapping, which is supported on the hardware itself, as well as lights. So if I choose I'll choose the morphing one, because one of the things you can add to your vertex format is morphing weights, which allows you to basically do morph between two different vertex positions, and that's just a very simple sample of a nice sphere turning into a coda-colored cube. Very, very simple. You can also, it also gives you the ability to do skinning, and there is actually a morphing and skinning sample, which hopefully very, very simple. But all that code is there for you to reuse, steal. Everything's licensed under the BSD license, so you can potentially you can include it, and you don't have to give away your source to any of that information. So yeah, I'm not sure what else you'd want to know really in terms of. There's a lot of power in PSP Link. If you can spend a long time trying to learn all the various parts to it, but for basic development, all you really need to do is run that application. That's all it should require. So I think that's probably coming up to time for the end of the presentation. Now I don't know whether there's actually any questions you've got relating to any of this.
Hi. So I see you use this remote joy utility to capture the video output from the PSP to the PC.
Yes.
Does it also work with the commercial games? Can you get video from those?
Yes, you can.
Oh, that's fine. Okay, gotta try this.
If you want to, well, I can probably show it you.
Oh yeah, cool.
Play Lumines on the big screen. That's the only game I brought with me, because it's the only game I actually play on the PSP. Just enable it. I don't know. Remote Joy also does remote. The reason it's called Remote Joy is it was originally designed as a joypad interface. You could have a joypad plugged into your PC and get it to control the PSP for development purposes. So you could have your PSP stuck in a rack, just sort of held up, and then you could just control it using the PSP. So the joypad. It'll also work on keyboard, so I can actually sort of put that down, and then we can. Yeah, it acts as a plug-in for the custom firmwares. Hopefully this will work. It'll probably not work now, just to spite me. Yep, okay. Yes, yes, yes. Stupid UMD drives, so slow. So there we go. And it works reasonably well. There'll be restrictions on it, but it wasn't designed to play games, but if it does, it does. So, there we go. Right. Is there any more questions on that? Well, not on that, but... Okay. All right. Thanks very much for coming. Okay.